Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Fred Schenkenberg. Hey, Carl.
Hey, Fred. I was, I mentioned this to you that I get the questions from time to time from readers and listeners. Mm-hmm. And there was one person who was frustrated with the difficulty of teams, and why not just have the design engineer on an FME, this is on an FMEA team, mm-hmm. Why the design engineer knows what the design is. Why do we need all these other people to participate on an FMEA? They know what's wrong, could go wrong with the design. And that, of course, began a correspondence with the person to mm-hmm. educate about why teams are needed, and which comes down to an interesting subject of blind spots. In the design engineer, this is what I was telling the person, is the design engineer may or may not have blind spots regarding that design they're doing. And you just don't know that. And one of the reasons we do engineering by teams is because we don't have the same blind spots. And so I thought that would be an interesting conversation with you today.
Oh, definitely. I mean, I've run into plenty of folks that are so close to the problem or the design they're working on, they can't see that if it gets wet, it'll melt, kind of thing. It's like they are conscious, smart, intelligent people that are focusing on solving the 10 problems that are top of mind for them and, add these features and do all this stuff. And they don't have the mental bandwidth to consider everything and to back up. And one of the stories I tell is out of the Henry Petrosky's book, Design Paradigms, where it was in a marble cutting yard. They had a quarry, and they had a piece of marble they were going to make a pillar out of, and for some structure, think ancient Rome kind of things. And it was the longest slab that the quarry had ever produced. And so they're sitting there having lunch looking at it, and they would normally put it on like 2 logs. So it was off the ground and they could then handle it and move it and work on it. And one of the engineers, one of the folks there said, that might sag a lot in the middle and break under its own weight. Why don't we put a 3rd log under it? And so they thought about it, because it's a lot of work to move this multi-ton chunk of rock. And so they thought about it for a while, and they stuck a 3rd log underneath it. And in the morning it cracked because the 3 logs were on the ground and not level and not equally supported. So it made a cantilever beam, which effectively increased a chance that it would crack. And it didn't. So it's a story that's like, we run into this all the time when you're doing failure analysis. You get a solution for one perceived problem and you apply that solution, but you don't step back and say, well, that change may cause other problems. And we are often so focused on solving the sagging problem that we don't anticipate or are blind to, well, now it could be a cantilevered beam and fracture in a different way. And we do that all the time.
Yes, we do that. And two stories come to mind. One is not really a story with a lot of specifics on it, but it's more of the concept of solving problems and things. But I've noticed in myself that in my personal life, or even in reliability consulting, is there are some very difficult problems. And sometimes when I can't figure out a good solution, and I'm working at it, I'm using all my spreadsheets and my analysis and thinking and everything. And sometimes I just have to pause and take a break, take a walk around, look outside, go back in, and then the solution comes to me. It's just an amazing phenomenon that sometimes you can't force it. And the relaxing and the extroversion, so to speak, a little bit, mm-hmm. and then all that analysis pays off, but it comes together. It allows you to think through to the solution. So I just wanted to share that.
Well, I know I've told this story before, but I worked, this director, she would stop by my desk every now and then and say, what you working on? What's new? And and I learned that if I said, well, I'm struggling with this, this thing here or this part, and it was infuriating because I knew she knew the answers most of the time. That's why I was asking her, but she would not answer the question directly. She would say, well, look at it this way. She had a process of helping me reframe, I think is the technical word for it. Look at it from another angle. Look at it from another point of view. Another, instead of using a microscope, get a magnifying glass out, or get stand further back from the problem. It was always look at it this way. Look at it from the chemistry point of view, or look at it that way. And I would go. She'd walk away, and I'm like, oh,
yeah.
And it was, but the blind spots are sometimes just built into the way we go about doing our business. And that's why I brought up Petrosky's book, because he talks about 8 different paradigms where we get in trouble as designers and engineers that, we forget about a mistake that was made 10 years ago. It might be a big problem at that time, but our company culture, we change over engineers, the people that actually worked on solving that problem or causing that problem, solving that problem, either moved on or retired or got promoted or out of that role. So they're not in the room anymore. To say, oh, remember this 1987 recall, blah, blah, blah. And if there's not a mechanism where that culture learns and incorporates that information and keeps it fresh, we're going to repeat mistakes. And that's where Petrosky talks about those paradigms of ways to recognize those kinds of things. That what we're talking about here is the blind spots, is being unaware of the potential or the design that we're doing or the approach we're taking or whatever. And it manifested itself in so many different ways. And I was starting to track it over my career. Industry wide, we've cracked capacitors every 5 years for 25 years. As an industry, we forget these little things are glass and they break.
Yeah, exactly. The subject of teams, it keeps coming to mind here because, I'm seeing, in my experience, I'm seeing 3 reasons why you want teams, and that that supervisor or manager that you mentioned that came by and got you to look at something differently, that's all part of what the value of the team is. Mm-hmm. And in one conversation with people, with a reader, they said, well, I'm a reliability engineer. I don't have anything to offer in understanding how often something can fail. I said, what? Well, that's the design engineer's role, and that goes back to that earlier story. Mm-hmm. But the point is I basically try to teach this person there's 3 reasons why you need teams and why you want to participate on teams. One is what we talked about on blind spots, and you can often offer a different way to look at something to help overcome blind spots. The other is the synergy from people talking together will stimulate conversation that often gets an idea popping forward.
Yeah, it's kind of the beauty of brainstorming, is that it's a free-for-all, yet it has a very distinct purpose to get your synapses working in ways that accumulate information and go, oh, let's look at it this way. Let's try this.
And you really need to set the vision for the team. And so when we're doing brainstorming, I'm talking with a team, or even when I'm teaching and trying to get that interaction going, I will tell people, this is the time to offer ideas. They may not be the best in the world, but sometimes there's a gem. And so we want to be open to other people's ideas, and we don't want to be critiquing them too heavily right at the outset. Yep. And so you can get that flow going. And the other reason is because different people have different backgrounds, and that's where diversity comes in. That's where the types of roles you've had, and a test engineer might have an idea about how something could be manufactured, and different. But you can bring your experience in, and that's really valuable. So I see those 3 reasons, and even then, you want to do the maximum you can on what we're talking about, or to overcome blind spots. But even then, it's possible to miss things. And that's another topic that I wanted to bring into the conversation. Oh, yeah. How do we minimize missing things because, whether or not you can do that.
Yeah, that's been a complaint that I've heard about with FMEA is how do you know when you're done? How did you know you covered everything, you thought of everything and stuff like that? And it says, well, one way you guard it is that you have multiple people with different experiences and backgrounds. And same for design reviews. The engineering design review is you bring in people that are not trying to build that particular project, but they have experience. They're other accomplished electrical engineers, for example, looking over a circuit design. And it's amazing that a fresh pair of eyes can say, oh, yeah, that's the problem. But that's contingent on who you got in the room. We don't have the universe of everybody contributing to this. We're not doing crowdsourcing for design critique, or problem identification or everything else. And the trouble is that I remember that I worked with one guy that we were doing design for manufacturing stuff, and the product he was working on got launched. And I said, so what do you do now? And he says, well, we wait for the other shoe to drop because something always fails in the first couple of weeks. And I'm like, well,
oh yeah, right.
And he was like, well, we can't anticipate everything. And I says, there are ways we can get better at that. And that's talking to Kirk and doing halt testing. And I, experienced that. They had a suite of tests that were standard, and they were blind to the changing environment that customers' expectations were and where they used the product and how they used it and all that kind of stuff. And it's not that we were unable to identify those things, is that it was back to blind spot, is they weren't looking for those problems. We're going to solve all the problems we had on the last project. And they didn't step back and say, well, what else is broken now? Or let's go one step deeper into the FMEA. And well, how about this potential one? And it turned out that about a month later, something failed. And it was, we got to update the design and change manufacturing or do something like that. And it was something that they identified during the prototyping evaluations, and everything else, but they waved it off as, well, that's a one-off. We don't have to worry about that. And it ended up being like a 2% field problem, which was a lot of money for them. But it's rare in my mind. Yeah, I agree with you that we can't identify every possibility of what's going to happen to our product, but we do actually do a pretty darn good job. And it's some teams, not all, some teams don't assess what they've learned about what could happen properly. They don't pay attention to those one-off glitches, or the 3 software engineers had to reboot this thing every time they did this, but they didn't report it because they thought it was a mechanical problem and figured they would catch it, and they didn't communicate it. And it turns out after the fact that was a big deal and delayed the project 4 months.
Right.
So sometimes we can't anticipate everything becomes the excuse of just ship it. And I find that
totally
disturbing.
Agree with you on that. That should never be the excuse. Let me just jump in on one or two things on this. On the subject of FMEA, if you do a really good job, and I've written a lot about this in terms of preparation and using the yellow stickies to identify things ahead of time in lots of ways. Making sure you understand the field history. If you do a really good job of preparation and a good job of facilitation, you can minimize missing things. You have the right team together, well-run meetings, etc. You can minimize. You'll never get to zero in terms of, you don't get a reliability of 1.0. There's always the possibility of failure, but you can minimize it if you do really well. The other thing is FMEA is not the only tool. And this is what's so important for reliability people. We know that. You may need a fault tree analysis. You may need a halt. You may need other tools.
Or hazard analysis.
Or a hazard analysis, exactly.
Different. Yeah, that reminds me of this. One of the things that was an unanticipated failure mechanism for early game controllers is that people would throw the controller through the TV or the wall.
Yes. Well, yeah.
We didn't think they would do that.
Dropping the cell phones, and there's so many things. This gets down to legal issues. You want to absolutely do the best job you can on every tool, but it's still possible you'll miss something. I did a presentation to the American Bar Association a number of years ago with a lawyer colleague who I've known. And we presented to it. And the title of the presentation was, Can You Anticipate Everything? And I was presenting that you can do a really good job of catching almost everything. But there's always that possibility. And so you have, and I presented different tools that can be used to minimize that, because that's what I believe. We want to minimize it. We want to get it down as low as possible, especially for the high risk areas. And you want to get that essentially to zero on the high risk areas. But it's a subject that you have to, it's a lifelong pursuit on managing risk, and the risk never goes to zero.
That's right. Yeah. Now, and I think the legal defense is they did due diligence. If you knew about problems and said, well, it's too expensive, or nobody will ever do that, or it's not, they waive it off, the thing that sets you up for liability. But by and large, most of us are very conscientious. If there's a safety problem, I haven't run into a team that I worked with that, shied away from those. Oh, it catches on fire. We got to fix that. It's not supposed to catch on fire. So we got to fix that. We'll do what it takes to fix those things once they become aware, especially safety stuff.
As managers, I think it's so important, because not everybody's a manager, but if you're in the management position, it's so important you understand the limitations of individual engineers. Yeah. And that's why you don't want to rely totally on one person. And you want to engage and inspire and enable teams to do engineering projects, especially around the higher risk areas. And so I think it's so important that not only the individuals understand blind spots, but that management understands it. And then as you get into safety issues, you can use multiple tools. So use an FMEA and maybe also a hazard analysis, and maybe also a fault tree analysis if you have tandem events that create the unwanted event. It's important to know the limitations of your tools, what they are, the limitations of people, how you can minimize those limitations.
I think there's a different tack that I would add to that. It's not just the tools that you're using. There's plenty of people that say, well, we did an FMEA, and they did it by sticking it in a meat grinder and chunking out a form and checking it off. It wasn't really an FMEA. But I think more importantly is there's got to be that culture. And I think it was kind of found in that one of the NASA, I think Challenger, I think it was that the O-ring one?
Yeah.
That the culture has to allow people to say, hey, this isn't right, or did you think of this piece of it? And because if I mention something in a team and they go, oh, that's silly, that's not ever going to happen, go away. And
that's a one-off.
Yeah. And then what's really hard to do, and I advise everybody to really avoid doing it, is 6 months later, don't walk back into the room after the big recall and say, I told you so. It didn't help. It's not going to help you. It's not going to help anybody. But the idea is that it's got to be part of the culture of it's safe to say, hey, that's not going to work. Or, hey, that's a great idea. Have you thought about this spot over here? Or, what if the customer does this with it? I saw my teenage kid throw the hand controller through the window. And, have you thought about putting a wrist strap on this thing? But if it's not safe to challenge a designer, the sole champion of the concept of the golden child, as I used to call him, then it's not. Those blind spots are not going to get it revealed. Those areas are just going to let the customer sort it out later. And I think, independent of whatever tools you're using, if it's not safe to say, that's an issue or that's a problem, or we need to check into that, people will stop making those suggestions or speaking up when they see something. And I think that's more devastating.
Yeah, and so there's a culture, and you're totally right, and that culture is so important. And if you're in management, then you help to create that culture. If you're an individual, you have to speak up. And this is what's so hard. And it's easy for me to say, I realize, on a podcast, but I've tried to live this value, and I've taught reliability engineers. And that is that you need to speak up even if it isn't in the culture. And you need to go into management, and because yes, you can get ahead by telling people what they want to hear. You can get nice kudos back from management by telling them what they want to hear. And you don't get those necessary kudos if you say something like, this is going to be a problem and need to stop production, or you need to halt what you're doing.
Unless you're working for an enlightened manager that says, that just saved us a whole pile of money. We needed to stop and fix that.
And it's probably another podcast, but the subject I'm getting to here, or sort of raising, and I think you raised it very well, is what do you do if you don't have that culture and you see something that isn't right? Yeah. And that's the point that comes forward with me, is that you still need to speak up, even if it's unpopular.
That's right. Just add that to the list. I'm laughing here because I'm ready to ask the audience, what do you think? And this one was sparked by a question that you got around FMEA, but it has a much broader context to it and situation, and it already led us to another part of it. But if you're listening to this, what's your take on this, and how do you go about identifying blind spots and making it safe, or how's the culture help you help the team find and solve the problems that an individual, I was going to say an individual alone. I'm thinking of my 6th grade English teacher. She always said I had better English every day. It's kind of, but the idea is how do you get around this stuff? How do you work with it, and how do you do that? And this came from a question that Carl received a while back, and we'd like to hear from you on these questions. And by the way, this topic that we just brought up right at the end of it, just before we started, where Carl's going, I usually spend a couple minutes thinking about the questions I've been getting and the types of stuff I'm seeing and stuff. I think you had like 5 or 6, maybe 7
5
topics.
or 6 sitting there just off the top of my head. Right. So it expands.
It does. And so if you want to have us talk about stuff that you're interested in, you got to compete with Carl, the idea generator here. But I do realize I'm giving you a hard time here, Carl, but you do pull a lot of ideas from questions you get and conversations you've had with people that are interacting with the podcast or our articles or writing and stuff like that. So please do contribute, help us understand what's on your mind and what your ideas and suggestions are or questions. Head over to ascendoverliability.com/go/SOR. A couple of ways to get in touch with us there. Carl and I and the other hosts of the show are available on LinkedIn and our About pages. And all those avenues work and have worked for other people. So please take advantage of that and get in touch. We'd love to hear from you.
Sounds good.
All right. So our current blind spot here, Carl, is that we don't know what's on our listeners' minds. Not all of them, anyway. So,
and we don't know how to end the podcast.
Well, yeah, we always have that trouble. Thanks, Carl. I'll talk to you later.
Talk to you later, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.